I know that this talk is technically titled all about open source hardware, but I wanted to sort of put the question out there probably on everybody's minds right away. So I've sort of titled my talk, Give My IP Away for Free? And we'll talk about that and the angst that, or the anxiety that you might have around that. So first off, as I said, I'm from the Open Source Hardware Association. So what is that? We call it OSHWA for short. You can find out more about us at OSHWA.org. One picture that I'm in the middle of there was one of our first boards of OSHWA. And so what we tried to do since the beginning was always have representation from kind of the legal world, so having lawyers who represent us, from the manufacturing world, having some of the companies who are building open source hardware be part of us, and researchers, so that we're tied in with academia as well. And our main activity at OSHWA that we do is we host an annual summit, and we've been doing this since 2010. So this, the other picture that's on the screen here is of the Open Hardware Summit. I think this was back in 2013 in New York City. And at these summits, what we try to talk about is kind of those three areas: new research being done in open source hardware, the legal ramifications of open source hardware and how any of the legal environment has changed, and then also the manufacturing side of open source hardware and building open source hardware and selling it and making it, and what it takes to run an open source hardware company. So this is a little bit of the open hardware timeline. So the things I want to point out here is that OSHWA did not start open source hardware. We didn't coin the term or anything like that. That was kind of all already happening, and there's already open source hardware companies that were producing hardware that was open source. And even back as early as 1997, there was an open hardware certificate program. So what OSHWA has done is we have kind of herded all of those cats together. So everybody who has wanted to learn more about open source hardware and to be part of the voice of our community kind of comes to OSHWA and says like, hey, we want you to be, promoting this kind of concept, or we want this definition, and this is the community definition that we want posted by OSHWA, and we want these types of best practices and things like that. So we have done a lot in terms of community building for open source hardware. And the other thing that we've done that I think is really important is kind of sort of become the default standards organization for open source hardware. So we host the definition, even though it was community written. We've also written best practices. I wrote a book with a number of community members on building open source hardware. And then we've got a certification, and that's furthers the standard to having sort of a certification that's couched within trademark law, and I'll talk more about that later. So currently, innovation has 4 paths to take, and you're probably all familiar with these 4 paths. One's the public domain. You can just give your stuff away. One is open source, and it's important to note, I think, that public domain is actually more open than open source. So in the public domain, you don't get anything back. You don't get any kind of attribution. You just put your invention out there, and absolutely anybody can use it for any reason without giving you attribution. It's completely in the public. So open source actually does have some more limitations to it than just putting your thing in the public domain, which I think is a really important caveat to recognize. With open source, you can ask for attribution, and you can, make people have a similar license to yours, so you can do like a share alike sort of thing that I'll also talk about later on. And then of course there's patents. You can get a patent. A lot of people in our community have chosen not to do this because of mainly 2 reasons. First, they're really expensive. So a patent, when you consider the fees and the engineering time and the lawyer's time, can be upwards to about $50,000 is kind of the average estimate of what it takes to be to have a patent. And then the other reason is that Patents are really only as good as you want to litigate them. So if somebody uses your patent, that's all fine and good, and they can continue to do so really until you litigate against that person and take them to court, which costs other kinds of money and time and things like that. And so a lot of people in our industry simply don't want to spend the time or money really obtaining a patent in the first place, and don't feel that that they necessarily have the stomach to or the desire to take people to court over over copying their invention if that were to happen. And then the final thing is a trade secret. So patents and open source are kind of interesting because really they share a lot of things in common. So both patents and putting something in the open source, you share the documentation with, either with the USPTO, which then posts it publicly on the website, or on the internet where, if you're doing something open source, you post it into your GitHub or your website or wherever you happen to be posting your source files, and that is made public by being on the internet. So a trade secret is different in that you basically just like hold all your cards and you don't tell anybody what you're doing, and you don't post any of the source anywhere, including the US Patent Office or whatever. And I'm American, so my familiarity with patents is with the US system in particular. So your country's system might differ a little bit, although a lot of patent systems are pretty close together. So what does it mean if you choose the path of open source hardware? What does that mean? That means that you're allowing people to remix, remake, remanufacture, redistribute, resell, and study or learn from your hardware. And really what this often looks like is that you've got your source files out there. So whatever it is that you needed to create for your source, people are allowed to either take that source and remix it, remake it, add their own flavor to it, add a different feature, and then put that documentation back out in the world and create a piece of hardware based on that documentation. So the source is really, when we talk about the source, we mean the documentation, and then the hardware itself is kind of a different entity, which is a pretty interesting thing because usually the documentation and if you're working in software, both the documentation and the software can be under a copyright license together. And in hardware, the source can be under a copyright license, but the hardware is kind of under its own thing. Either that's a patent or open source hardware certification or nothing at all. It's important to remember that hardware is also born open. So copyright is automatically applied the second that you make something, or that you write something or create a document that can be protected with copyright. Hardware, you have to actually go out and get the patent. And so otherwise, it's basically just sort of open with no protections on it. And what I'm talking about here, when I talk about hardware, I'm talking about atoms versus bits. So hardware is anything that has atoms rather than bits. So anything that can be in the hardware realm, things like fashion, like clothing, microcontrollers, electronics, 3D printers, all that stuff. I think like the electronics and the 3D printing are kind of the fields that open source hardware has started from, but there's a lot of other fields out there that are also adapting it and applying it to their thing. And sometimes it's not exactly, it's kind of different than where we came from, which I think is really great. So atoms also make up things like medicine. So medicine could be considered open source hardware. Anything that is bits is like the software to run it, or, like I said, the documentation, the uploaded documentation, things like that. And so then when we're talking about source, what exactly is the source for that hardware? And basically, stated really simply, it's basically anything needed for someone to make a copy. That's really it. as long as you've got enough source out there that somebody else could come along and make a copy of your thing, you have provided enough source for your thing to be open source hardware. A lot of times what this looks like, especially, you know, in the electronics field, for example, it looks like having your schematics posted. In the 3D printer world, it might be the CAD files. If there is hardware that is also running code and firmware, the code and firmware also need to be open source. It can also just look like hand drawings. And just as a reminder, all of these things are copyrightable things. So again, the source is all copyrightable, which you can apply like a Creative Commons license to, or a GPL license, or any of the copyleft licenses that are out there. There's lots and lots of licenses to choose from that are an alternative to copyright, but that is something that is that needs to be open as well. The source needs to be open as well to make it open source hardware. And so the design that I have as an image here is actually a face shield. So in this new exciting era of COVID that we all are living in right now, this is the source to produce a face shield. So this was, I should say, this was part of the source. So their source can look as simple as this. It may not have any sort of software or firmware or whatever. It may just be you know, a drawing that is effectively your source for your object. And so these face shields are the face shields that came from the University of Wisconsin. They were designed there, and they're open source hardware, and they are the face shields that Ford is manufacturing in the hundreds of thousands of units. So, you know, again, for this, for the rest of their source, they had like measurements for, like, you know, the elastic headband and the brow foam and the clear shield. And that is their source. And then this is like kind of the schematic of how it all goes together. So it doesn't have to be complicated if your hardware isn't complicated. There are things in open source hardware that don't have code and firmware, and I think that's really important to remember. So the benefits of open sourcing, let's talk about this. So one of the first benefits is you get attribution, which is kind of, if you think about it, it's like getting a citation if you're in academia, right? Like you get attribution back. So anybody who copies your hardware has to give you credit, okay? You get provenance. So you get, you know, if somebody's copied one person's hardware over here and then it's gone from here to here to here, you'll be able to hop back through those changes and see what the original thing looked like and how it's kind of evolved, which I think is a pretty cool benefit of open source hardware. You'll get other people, if you add on a share alike clause to your open source hardware, you will get people sharing alike. And what that means is basically they have to keep the same license. So what that means is that you release your hardware as open source, nobody else, and you say like, hey, this has to have a share alike license on it. That means they also have to release whatever changes or modifications they make as open source hardware. They cannot then patent that or keep it as, you know, a trade secret or whatever. They have to share that same license alike. Open source hardware encourages collaboration and feedback. So I've never seen anybody invent something in a vacuum. And I don't think that that's how the history of invention works either. And so this really encourages putting that collaboration up front and putting the collaboration in the limelight. And a lot of times when you have collaboration, you've got more heads working together and you're allowing more feedback on whatever it is that you're creating. And feedback is a really important loop into creating products that people want. Open source hardware also encourages community. So there's a lot of community around open source hardware projects. If people happen to know of a really popular microcontroller that's open source, the Arduino platform. So the Arduino team, you know, if they went away tomorrow and said, we're not going to produce Arduinos anymore, the Arduino product would live on because there is such a strong community around that platform, and because other manufacturers could keep producing basically Arduino derivatives. So I think that's also like a really interesting way to think about open source hardware, is think about like, are you building this thing, you know, just for yourself, or are you building this thing because you want it to live on in the world that is bigger than yourself? And then finally, I really think that open source hardware incentivizes innovation. So a lot of the patent system is kind of broken in ways that it was never intended to kind of act as it currently is. And in some of those ways, so, you know, I don't know if any of you have heard of patent trolls, but currently it's possible to get a really broad patent, which is not supposed to be possible. Patents are supposed to be only for unique inventions. But for an example, like Apple patented rounded corners on their phone. Rounded corners aren't really that unique. You can find rounded corners, you know, all over the place in the world. And so, and I don't mean to like, you know, there's lots of companies that do this kind of things, not just Apple. But there's also a lot of times in the past, you know, patents were created so that people would feel incentivized because they would have this monopoly for X number of years on their product, and therefore be able to make a lot of money on that. But when I go into a store, I don't know about you, but I never look at how many patents a product has when I'm choosing to purchase something. I look at the cost, maybe the color, the size, if it's got the features that I want. I look at things like that. And it turns out that a lot of consumers also look at things like that. And every talk I've given, I always ask the audience if anybody buys things because of the number of patents it has. And I haven't ever had anybody raise their hand that that's why they purchase a particular product. And so I think that what that shows us is that it's not, the patents themselves, aren't incentivizing innovation as they once did. So currently, technology runs a lot faster than the patent system works. And so by the time you have, like, the USPTO issues your patent, you are most likely onto another version of your product. By the time your patent runs out of its monopoly that you can have on it, a lot of times your hardware or your product, whatever it is completely obsolete. So currently in the United States, patents run for about 7 years. And I don't know about you, but I definitely have I've probably had 2 new phones in the past 7 years. A lot of things run faster than just that. And so what we're finding in the open hardware community is people were feeling that patents really didn't incentivize their innovation. They didn't feel like because of a patent they would make any more money. And in fact, they felt like they would have to spend more money because it's expensive to get a patent. So they ended up just releasing their stuff as open source. And what that does is it makes their companies hyper aware of what their community wants, of what their customers want. So they have to constantly reinvent and add features and do things to keep their products fresh. And so really that is innovation that happens a lot faster than a 7-year patent cycle. And stop me if anybody has any pressing questions on any of this. I want to make sure that you're saying your questions while they're on the top of your mind rather than waiting till the end.
Yeah, it looks like there was a comment in the chat as well. Just says the reason why you can't get clones, or you can get clones for $5 on Amazon, is similar to what you're talking about with the rounded corners for Apple.
Exactly, yeah. So you can like buy, I don't know what Apple's phones are technically at right now, but you can like buy like an i9 from, you know, a website overseas and ship it to your house, and it's not the i9. But yeah, so I mean, that's the other thing, is that unless you're going to litigate your patent, a lot of times you're just having a patent doesn't stop anybody from copying you. And there was a talk by Nathan Seidel, who is the owner of Spark Fund and happens to be my husband as well. But he made a talk a few years back that was a TEDx Boulder talk. And his whole sort of summary from that talk was, if you've created something that can be sold, it will be. So if you are successful enough to have made a good idea, other people will copy it. It's just the nature of how globalized our markets are right now and how easy things are to access on the internet. And I guess what's kind of different too about, you know, the patent industry versus the open source hardware movement is that, you know, the patent industry is more like, oh, like we're going to litigate, right? We'll take you to court. We got to, you know, make sure that we're the only ones who can hold on to this innovation. Whereas the open source hardware movement says like, oh, that's a really big compliment to me. Like somebody thought that my innovation was good enough that they wanted to copy it. That's amazing. And so now I want attribution for that. So you have to put my name on that product of saying like, this product was originally came from, you know, so-and-so or whatever company it is. And that is more incentivizing for some people out there who want to do open source hardware. So there are limitations on the source, and I want to go over those. So hardware consists of many parts, and currently not all parts are open source hardware, right? So this movement is pretty young. Like I said, we started out in electronics and grew into 3D printing and are growing into other areas. But just in the electronics industry, for example, you don't always have control over all the parts. Meaning like, unless you're the company that makes integrated circuits, you don't have control over the source of that integrated circuit. So a lot of what we kind of do is we state that like, you know, as long as other people could get that integrated circuit or the part that you don't have control over, and as long as it comes with a data sheet or whatever people might need to know to drill down into different layers of it, then you can still use it within your hardware and consider it open source. So we don't state that, you know, like you have to have every single thing, every resistor on your board and every integrated circuit, every aspect of your hardware be open source. But the parts that you have control over, those are the parts that have to be released under open source and that you have to share the source with if you're wanting to make an open source hardware project. And this is basically because your intention is really what matters here. So we want to make sure that people, that you are giving the world the right intention of how you want your product used. So if you're releasing something in open source hardware and you're saying, I have control over these parts over here, and my intention on those parts is to share those with you, then that can be open source hardware, even though sometimes, like I said, the IC isn't always open source as well. All right. And just a reminder that, again, open source hardware isn't for everyone. So people, you know, a few years back when I had just started OSHWA, people would come to me and say, hey, like I put my source files out there and somebody copied me. And I would say, that's great. Like, congratulations, you've done open source hardware. And what we realized was that people wanted to be doing open source hardware, but they weren't really emotionally prepared to be copied. So we actually created a checklist and added, are you emotionally prepared to allow your project to be copied to this checklist so that everybody recognizes the fact that if you do it right and if your product is popular, that people will copy it. And so that's really, you know, I think one of the big things to get over with open source hardware, because I think an invention can feel very much like your baby, right? Like it's your personal thing that you're very attached to. And so sometimes I think it can be really hard to see somebody taking it in a different direction or in a route that you had never considered before. And so what we've also done to have a little bit more protection on open source hardware is we started the Open Source Hardware Certification. And what the certification is a symbol and a country code and a number that is given to you when you show us that you've got all the source for your open source hardware and your product should be open source. So what the certification is couched in is trademark law. And so the symbol that we give you is under trademark from us. And so this way, if somebody is kind of maybe a bad player within the open source hardware movement, if somebody just copied your hardware without giving you attribution or without doing the share like license or something, and went to the level that they just, you know, like totally just 100% blanket copied without any kind of attribution, any sharing of their source, whatever, and the certification number is on it, then you can say, hey, you know, that's a trademarked item, and you need to, you know, either take that off or you need to give attribution and share your source. And a lot of times what we found too is that people just didn't realize that they had to do that and thought, oh, open source just means like I can take and copy it. So we've spent a lot of time letting people know that you can't just do that and that you have to go through the definition and jump through the hoops that you have to do in order to create a derivative of something that's open source hardware. So the certification was kind of an answer to that, to be able to put a little bit of protection on the open source hardware that people were creating. And we have around 1,000 products that are certified in a lot of different countries. So it's a pretty new certification. This was developed in 2017. But the really cool thing that has come out of the certification is now we also have a database of all the open source hardware projects that are out there. So it's created a directory of everything that is being open sourced from, and this is one of the things that's on there, an open source hardware hammock, all the way up to open source hardware ventilators for COVID. And you can learn more about the certification on certification.oshwa.org. You can go through the steps of seeing what it takes to apply for a certification, or you can totally apply for the certification and get your hardware certified. So a good question that people often ask is, can hardware survive on trademark alone? And if you look at the fashion industry, it's really interesting what's happened. They are not allowed to copyright their images or their files to create clothing because clothing is a necessity, so you cannot copyright it, and you cannot patent it for the same reason. So they have had to survive on trademark alone. And what happens in fashion is that they innovate for a fall collection, a winter collection, a spring collection, and a summer collection. So what we've seen when places are only allowed to survive on trademark is that innovation happens more frequently than places that aren't. And so I love pointing to the fashion industry, stating that that the products don't need a patent to survive, and products don't need a copyright to survive. So I talked about the Arduino previously, which is a really good example. I think if any of you are in electrical engineering, you've probably seen this, or in even maybe in some of your software classes, the processing languages tied to the Arduino platform, if you've ever used that language. So Arduino is a microcontroller that was started out of a university. And the university was closing, and so they decided, hey, instead of just having this hardware kind of be under this umbrella of this closed university, let's open source it and see what the world does with it. And what's happened is many different derivatives have been created because it's open source. And some of these derivatives have been allowed to use the Arduino name, which the Arduino name is important to recognize that is trademarked. And so you can't just use the Arduino name if you feel like it. But some of these that you see in here that do carry the Arduino name have gone back to the Arduino company and are either paying royalties to use their trademark or have some kind of other agreement to use their trademark. So a lot of business that goes on in open source hardware isn't that far off from how other businesses work. It's really just like an IP switch that sort of happens and allows you to make more derivatives from that hardware than would be possible with a piece of hardware that's closed. But there's a lot of other revenue streams that you can take. If you can think of a revenue stream that happens in like regular business, you can most likely apply it to open hardware. The big change is just that you're sharing the IP. I think the other interesting thing to note is that, I don't know that the Arduino company themselves would have made all of these different derivatives, or even thought of the different derivatives, or recognized that there was a population that wanted the different derivatives. So there's like the purple circular microcontroller in the upper hand corner is for sewing. It's for making wearables. So sewing like LEDs into your clothing and things like that. And the original Arduino platform, and the people that made that may have never gotten to that level of like, oh, you know what? I think that somebody might want to sew this into their clothes. But allowing it to be open source made people basically look at the functions and at the form factor, and then be able to alter that hardware because it was open source. And I think there's a lot of potential in this field. So of course, we're living in this crazy new world of COVID right now. And what's happened is that we've seen a lot of places do some form of open source hardware. So the projects that I've got listed here, both of these projects have gone through certification. The one project that's got like a little door and a food bag coming out was a project for a touchless food delivery system. So this way they could package up the food in a way where humans weren't touching it, and it was kind of like being packaged by a robot, and then it would like come out this door at the person who was going to take it and eat it. And then the other image on here is for an open source ventilator that was certified as well. And so I think it's a really interesting place where we're at right now, because we've seen a number of other companies who have traditionally done very closed source hardware open up in ways that we weren't expecting. So one example is Medtronic. So they're a medical supply company, and they opened up parts of their ventilators because they just needed more minds. They needed more efficiency and people to be looking at the problems and solving the problems on a global scale rather than just within their own company. And so they opened up some of their source. They didn't do it in a way that fully open sourced the hardware, but it was like definitely a step in the right direction, and definitely is interesting to see what kinds of things can happen when you collaborate and share, and what happens within our society that necessitates that collaboration and sharing is also kind of telling and interesting to see when that happens, and what kind of events spark that to happen. Leah, did you just unmute yourself? Did you want to say something?
Nope, I didn't unmute,
okay.
So it might have been somebody else. Sorry.
Okay. All right. So I think it's also something that I used to think when I just started this, the Open Source Hardware Association, people would come up to me and say, oh, okay, well, this is nice that it works in the electronics field, but it certainly doesn't work in every field. And they would usually give the example of the medical industry. And I would say, yeah, okay, that maybe that makes sense. Maybe the medical industry, like, we don't have open source hardware in the medical industry or something. But I think what this has really shown us is that open source hardware definitely has a place in the medical industry. And it's really important to also remember that open source hardware only speaks to the intellectual property behind it, right? Just to the IP. And what other certifications you need in terms of the medical industry, like FDA certification and things like that, your hardware will still have to be put through. Open source hardware doesn't negate the fact that you need to go get other certifications and hold yourself accountable in those kind of ways. But I think this has shown that we definitely can have open source intellectual property in the medical field and become a better society because of it. So I really believe that open source hardware empowers exploration, personalization, and invention. And I think as students, this can be a really empowering thing to also put on your resume so that you can state, like, I have contributed to X number of open source hardware projects, and here's my name, and you can see that. If you've contributed to a patent, you might not always get your name affiliated with that patent. A lot of times there may be a lead inventor affiliated with it. Sometimes patents just are end up kind of like with the company that you're at, and you get no attribution whatsoever. So I think that for students, if you're working on a project, it's better off to open source it so that your employers can see your work, so that you can produce a portfolio of your work, and you're able to like say like, hey, look, you can see my work all the way from the source down because I've shared all of that with you, instead of it being like, well, you know, it's kind of a black box over here and I don't really want to tell you how I did that part or whatever. I think that that open source hardware can sort of be a ticket into employers understanding not only how you think, but also how you collaborate and how often you've collaborated, and what that kind of looks like from an overall product standpoint. I think that can be really empowering for students. So if people have questions, I can take those at this point. I am not sure if I can see the chat from here.
Yeah, it looks like, yeah, there's just another, just a follow-up to the initial Amazon kind of question. Were you able to see the chat at all?
I can talk about it because
yeah, go ahead.
Yeah, so when you mentioned, so I had a feeling Arduino's open source, but I wasn't like completely sure. I was more or less talking about how because it is open source, many companies are allowed to like basically get the schematics and reproduce an exact, not one for one, because you also mentioned that sometimes they might swap out a piece of hardware for a cheaper one. Or I've noticed in like cheaper Arduino boards, they tend to skip out one component that isn't super necessary, but will be necessary if you accidentally, I think the chip was, it dealt with voltage difference, and then it would just, on the default Arduino, it would handle like, oh, there's too much voltage, send it over here. But then on the clone, it wouldn't have that. So if you had a power surge, all of a sudden, your clone's just toasted.
Yeah.
But I also just find it very fascinating how like, because it's open source, you can get, instead of spending like $45 on like a normal Arduino, you can just spend $5 and get a project up and running really quickly.
Yeah, so that's absolutely the beauty, and the beauty to consumers, right? So like it can mean cheaper products, and sometimes you're exactly right, where like there might not be a voltage regulator on a board that's a derivative, but there's a lot of people out there who might not need the voltage regulator, and as long as you understand what you're doing with, you know, the voltage and how much you're putting in, for a lot of people that works perfectly fine. For some people it totally, you know, they get bitten, and it's a bummer, but I think you know, again, like that is a feature set that you've chosen and that a company has chosen, that like we want to sell this feature set, and then they see if the markets want that feature set or not.
And it looks like, yeah, that was the only question in the chat right now, or point.
Yeah, so I want to hear from other people. I mean, does it seem clear what open source hardware is, or do you have other questions in various areas on what open source hardware is? Was I able to describe it enough for you?
Yeah, I understand the general idea of open source hardware.
Okay.
One question I know that some of our fellows have had, Alicia, is how can you really get started in this direction? What are some good jumping off points?
Yeah. So, I think a great place to get started is actually like, look at some open hardware out there and like clone it. Like that's why it exists. Remember, it exists to study and learn from as well. So you're free to get some, get the source files from a company and just tinker around with them, like create something that, that you've sort of wanted to create, but, or wanted to make a derivative of, but maybe don't have like all the education yet to create the whole product start to finish. So use what's already out there, stand on the shoulders of giants, right? If you've always wanted an Arduino with a different feature, then just get the Arduino source and add your feature to it. Maybe all it is like making it pink or something, right? Like that's perfectly fine. If that's your first project, I would say like go for it. And then, I think there's a lot of help along the way too in their Arduino community of people saying like, hey, like I want to do X, Y, or Z. Like I want to, create something that has a different feature or whatever. And there's a lot of different Arduino forums that you can go on to say like, has anybody done this feature before? Or like, what do I need to do with it? Are there libraries that already exist? Kind of educate yourself around those types of things. And then it makes it even easier to start your very first project or product. Remember that you're free to resell this stuff too. So you can create a company based on open source hardware and standing on the shoulders of giants of other open source hardware companies. And then I would say, from there, like once you kind of have gotten that level and that comfort of like, oh, okay, so this is how it works. Like I download this source and then I can like tinker around with it and do different things. Then if you're looking at this as like as a way of inventing your own product, I would say, look at, of course, what's already out there first and figure out, what the source is on stuff, figure out if things are patent protected or not. And then kind of make your product based on the feature set that you want, on how that feature set is different, right? You're going to have to make it different, especially if it's patented. This is the other fun thing about patents is that as long as you change something, then your thing is a new thing. So if there's like a patent on a stool that has 4 legs, you can make a stool that has 3 legs. And that's a new thing in the eyes of the USPTO that can be repatented or whatever. So a lot of the things within, the patent industry, even if you find a product that's patented and you've had this dream forever that you wanted to like create this product, and then you realize like, oh, there's already a patent on that. You can just basically like sort of go around the patent and make your product different in a way that is no longer infringing on that patent. And then you can still make your product. But yeah, I would start off by like kind of educating yourself on what's out there and what is what's available, and then make it have a different feature set than what's already out there. And I think the other important thing is doing things like making sure that there's a community who wants your product. So you're going to be user number 1, and you're going to make your product for yourself, right? But hopefully, like I said before, you've got some collaboration going on, and you've got people who will give you feedback on that product. That's a really important part of the user experience design and making sure that your user interface is like solid. But then I think the third piece of advice I would give is to make sure that you're not getting wrapped up in the engineer's curse, right? So you're not getting wrapped up so far into like making sure that your product is so perfect and that you have everything thought out before going to market, because you can do that for years. You can spend loads of money making sure that absolutely everything is the perfect way that you want it, and you can cost yourself years worth of money where people might have bought it 3 years ago with the version that you were at that point. So make sure that you have a buy button on your website, right? Like people can't buy your product unless you give them a way to buy it, and make buying it easy, right? So like you might, I don't know, like nobody's going to like be like, oh yes, you can only buy my product with a cashier's check. But you know, 10 years ago, before like there was like PayPal and like the internet and everything, sometimes things on the internet were like really hard to buy, where you had to like fax people your credit card form or whatever. It was crazy. But like, you know, in that same token, just like make it easy for people to give you money. There's lots of software out there. You know, don't feel like you have to start everything from scratch. Like, get whatever accounting software works for you, get whatever website software works for you. Don't worry about like building absolutely everything from scratch. Worry about your product or your project that you're focused on the most. That's what should be your main focus. Everything else can kind of be outsourced. And I feel like, you know, take what's out there, right? Like take the wins. So
I know that you mentioned formally that this was, you know, U.S. Patent and trade is U.S. obviously focused. Is there any places for our international students that you know of that they can look for patents maybe that are in their countries?
Yeah, I mean, so every country has a patent and trade office. So they're kind of called different things, but if you search your country for, you know, the patent office, it should come up fairly easily. And I think what's interesting is that a lot of places, the patents systems have kind of stemmed from like the early, like the 1800s European patents. And I think, you know, Americans' patents have kind of changed every once in a while. They've changed how they're run. Like Europe right now is looking at the European Union is looking at the economic value that open source brings their countries, and that includes open source hardware. And so I think there's like a lot of places that are starting to recognize that that the patent system might not be the only system to have for intellectual property. And I think the other thing that is really interesting, like, so a lot of times, I always feel like it's disheartening and kind of xenophobic whenever I hear things like, oh, it's just going to get, you know, knocked off in China or whatever, right? And I think that the Chinese patent system is really interesting too, because they didn't have a patent system until 1984. So that's pretty, you know, early. I mean, that hasn't been like that long, right? Like we've had our patent system it was like in the 1800s or something. And so when you think about the sort of man-madeness of intellectual property, right? Maybe it's just that China is better at sharing. And they've had a notion towards sharing until 1984 when they got their patent system, right? But maybe like in other countries in like in America, we're just so used to like hoarding innovation because we've had this patent system in place for the last 200 years and we're just not as used to sharing. But one of the things that I really look forward to, the younger generations that are coming after me, is just that like you all seem to be all about sharing, which I think is awesome. Like everything from like on social media and like just like there's so many things where like you're like the younger generation's default is sharing, instead of thinking that like, you know, I have to like just do it all myself and pull myself up by my bootstraps and whatever. Like there's so many misnomers that are out there about business that like that doesn't exist. And so I really look forward to like what business is going to look like and what innovation is going to look like when there's a generation of students out there who just default to sharing.
That's a really great point. Does anyone else have any questions around open source or open source hardware? See if anyone. Right.
I don't have a question, but I have like feedback. I'd like to say this was really helpful, and thank you for the clarification, because this is going to be the first time I'm going to be contributing to open source, and
Great.
I didn't really know what it was, but now I do. So thank you so much.
That's awesome. I'm so glad to hear that. And everybody should know too, like if you've got any follow-up questions that you think of later, like feel free to ping me offline or on Twitter or like whatever. I'm available, and you can always email me, and 10 years down the road, whatever. I'll also note, you know, one question I didn't answer that I realized just now, like usually gets asked, is that like, how does it work where like if you open source your hardware, then somebody like can't come patent it. There's something called there's something called prior art. And so basically when you're putting your open source out there, when you're putting the source out there, that is creating prior art. And so the USPTO and other patent and trade offices search for prior art. And if they find any sort of prior art, then like whatever patent application is there cannot get a patent, because they're like, oh, there's already something over here that's like the same thing, and so therefore you can't get your patent or whatever. So prior art protects open source in a way, in that kind of way that doesn't allow people to get patents on top of what you've done. And as part of that note, I will also note that one of the reasons it's great to have the certification is that by creating that directory, we hope to give at least different patent offices something to search for. So they can search for open source hardware in that kind of way and say like, oh yeah, okay, we see that, you know, X, Y, and Z projects have already been created, and therefore like we can't have that patent. Because currently, you know, the patent and trade offices don't just like search the internet. They search like very specific like journals and their own databases and whatever. So they can miss some prior art. But then you can also go back and like prove that you have prior art and things like that. But I just wanted to mention that like prior art is what protects open source to be open source and to not get a patent on top of it.
Really great, yeah, clarification. All right, well, this kind of ends our time. You're getting some thank yous, and that was great in the chats as well. So thank you so much for your time today. We really appreciate it.
Absolutely. Thanks for having me.